In the first video, we skipped really going over the proof of the product rule in detail. So I'm going to do that now. And if you feel like you either understand it from reading it or you just don't want to watch this video, you can actually move on to the second one. But if you're curious, we absolutely can prove the product rule. So if I'm taking the derivative of f of x times g of x, we could start this by thinking of this as the limit as h, or delta x, I'm going to use h, as h approaches 0, of f of x plus h times g of x plus h minus f of x times g of x, all of that over h. All right, so we said this limit gives us the definition of the derivative. So in order for us to really understand this rule, we're going to have to manipulate this in a little way. So as I'm looking at my limit as h goes to 0, I'm going to keep my first term, f of x plus h times g of x plus h, but I'm going to add and subtract. So I'm going to put two additional terms in the middle, but they're going to be one is added, one is subtracted. So I'm going to subtract from this f of x times g of x plus h. And then I'm also going to add f of x times g of x plus h. And then I'm back to my minus f of x times g of x from my numerator. So all of that to say that these two terms in the middle here, this negative f of x times g of x plus h, and this positive f of x times g of x plus h, those two are the terms that I added, but they undo each other, right? They're opposites. So they just cancel each other out. But we're going to need that manipulation to help us understand the product rule. Okay, so now if we could just go ahead and group these a little bit differently, kind of like the last limit proof we did, proving the derivative of the sine of x. So right now, I notice if I kind of look at these first two terms in my numerator, that they both have a factor, a common factor of g of x plus h, and then my second two terms in my numerator both have a common factor of f of x. So we could kind of regroup this and think that this is the limit as h approaches 0 of, I'm going to pull out my GCF, so f of x plus h times g of x plus h minus, oh, you know what? I'm already messed that up. Sorry. My GCF I just said was g of x plus h, not f. So I'm going to pull out my factor of g of x plus h. I'm going to multiply that with f of x plus h minus f of x. All right, so again, all we did was pull out a factor of g of x plus h there. And we said that was the common factor of these two terms. All right, then we're going to add to that our next big terms we grouped. We said their GCF is just f of x. So I'm going to factor out f of x and keep g of x plus h minus g of x in my parentheses. And this is all over h. So again, all we did was pull out the GCF of those two groupings. We said for the first one it was g of x plus h. The second one, it was f of x. All right, now we know that we could break, if we have, we rewrote this as a limit of a sum, so we could rewrite this as a sum of limits. So I could rewrite this as the limit as h approaches 0 of g of x plus h times f of x plus h minus f of x all over h. And then I could add to that limit as h approaches 0 of f of x times g of x plus h minus g of x. All of that over h. So again, we just broke up our limit as we had a limit of a sum. We wrote it as a sum of limits. And now we can use another limit property that when we have a limit of products, we could rewrite that as a product of a limit. So where we have this multiplication between our GCFs, we could rewrite this So we essentially will have 4 different limits in this next equation. So I have the limit as h approaches 0 of my GCF, g of x plus h, and I'm multiplying that with the limit as h approaches 0 of f of x plus h minus f of x, all of that over h. Because remember, I don't need g of x over h over here if I'm multiplying. All right, so then we can add to that the limit as h approaches 0 of f of x, and we're going to multiply that with the limit as h approaches 0 of g of x plus h minus g of x, all of that over h. So we have 2 limits being multiplied and then all of that being added together. So now if I go ahead and evaluate this for h approaching 0, well, for this first piece, the limit as h goes to 0 of g of x plus h, that just yields g of x. The second piece, when I plug in my 0 here, this is literally the definition of the derivative of f of x. So that yields f prime of x. Like that limit yields f prime of x. All right, we have our plus sign here. The limit as h goes to 0 of f of x. Well, there's not even an h, like there's no place to plug h in, or 0 in for h. So this is just f of x. And then lastly, this last piece, the limit as h approaches 0, again, this is literally the definition of the derivative of g of x. So we get g prime of x. So all of that to say, when we put all these pieces together, we get g of x times f prime of x, which is the same as f prime times g, plus f of x times g prime times x. And again, we remember that multiplication and addition are commutative. So we're more likely to see our product rule written this way. All right, that was so much fun.